Hello and welcome to a standalone video where I'm going to run through the modeling process for this practice bracket part. Now we discussed this part in class, but I'm going to go through the steps for modeling this. Now, as we discussed in class, it's nearly always worth your while spending a few minutes at first coming up with a plan for how you intend to model the part, the steps you'll take. As I said, we discussed this in class, and due to the way this is dimensioned, the steps that I plan to take here are to model this flange first here, and I'll set it up in such a way that my planes and my origin are centered on that kind of lobed flange there. So I'll do that part first, or that feature first, and then what I'll do is I'll extrude out this inverted T-shaped section here, and then I'll model this cylindrical feature here, and this face at the end, and then finally this cylindrical boss at the top here. Okay, so I'll go into Solidworks. I've created a new part already. So what I'm going to do is to create that lobed flange at this end here first of all. So I'm going to model that on the front plane, and I'm going to set it up in such a way that my origin will be, if we look at it in this view over here, my origin is going to be right at the center of that part there. That also lines up with the top surface of that inverted T-shaped section here as well. Okay, so if I set that up with my origin in the center, then my top plane will be running right along that surface there. My right plane then will be running through the center of the part as well here. So spending a little bit of time thinking about which is the best feature to create first, and with an eye to where your planes and your origin will be lining up, will save you time and effort later. Okay, so what I might do is I might take a snip of this view here just to get some of the main dimensions. So within Windows 10, what I'm doing there is I'm hitting Windows Shift and S at the same time, and it brings up that snip and sketch tool, I think it's called. So that allowed me to take a quick snip of that, and then I can paste that in here with Control and V. I can paste it into my working area in SolidWorks. Okay, so it's this lobed flange here that I'm going to model first, and I'm going to model that on the front plane. Create a new sketch, and this origin here, now that's going to be the intersection of the front plane, top plane and right plane. So I'm going to rough out the shape of this thing here with say one large circle in the center and two small circles either side of that, roughly something like this. Okay, now I'll make sure that these then are horizontally across from the center, from the origin. And I'm going to draw in some lines then coincident with this circle that are going to be a tangent to this circle. Similar over here, a line coincident with that circle, tangent to this circle. I'm just moving around till I see the automatic relation being added. Okay, and I'm being careful here. I don't want to put it coincident with the quadrant of the circle there, the bottom part of the circle. I'm making it coincident with the circle somewhere back here, and then tangent to the main circle, the large circle. Okay, so you should have, you can move things around and see whether those tangent relations are in as you want them to be, but you should have those lines that are tangent to the small circle and tangent to the large circle. Okay, so these are all tangent. This line here hasn't gone in as a tangent, so what I can do is manually click that line we click that line, control and click on the circle, and add in a tangency relation there. So that now should be, if I move those circles about, you should see those tangent relations being kept. Or if I change the dimensions of the circle either, you'll see that these lines will always stay tangent. Okay, so I can start dimensioning that now. So the large circle here is to be, well, it'll wind up being a radius 75 curve on it. So what I could do here at this stage is I could use my trim command, power trim entities, and remove parts of those circles, and then put a dimension of radius 75 on this here. Okay, see it rescales everything in my sketch then to suit. Okay, the smaller ones, now it's here in the drawing as diameter 42, but actually radius 21 would probably be more appropriate on that curve on the outside. So I'm going to trim away these parts here, and I'm going to dimension those to be, I'll dimension this one here to be radius 21. Okay, and I could dimension this one here as well, or what I could do is highlight both of these curves here and make those equal in radius. Okay, let's see if I was to change this now, both of those would change. Okay, I also want to put in these, what will become the two holes in that flange, so they'll two circles with diameter 21. So circle here and here, and I'll do the same thing again where I'll dimension one of these, say diameter 21, and I'll make the other circle equal to that. So equal relation on that. Okay, I want a dimension then center to center between those two holes there of 188. Okay. See what's happening here. They are the correct distance apart, but they're not equidistant from that from the origin there. So there's a couple of things you could do. What I could have done early on, I suppose, is I could have put a center line down through the middle of this part here and used symmetry rather than equals relations. There's always a few different ways of doing this. So what I could do is I could put a center line here between these parts. Between the center lines of the holes, and I could say make the midpoint of this line coincident with the origin, for example. So if I right click on that and select midpoint, then control click on the origin, I can make that midpoint concentric with or coincident with the origin. That's one way to do it. The other thing I could do is I could have a center line running vertically down through the, from the top of this, from the top of that arc to the bottom of this arc here, and I could use a symmetry constraint where I select the two circles and select the center line here to make them symmetrical about that center line. So either way would be fine. In any case, that sketch now is fully defined. I'm going to close out of that sketch and extrude that by a distance of 22. So create an extruded boss base feature and extrude it out by 22 millimeters. Okay. So the next feature I want to create then is this inverted T shape feature here that has that's going to be in total 267 millimeters in length from the front plane. So that face of that flange that I've just created, it's going to be 267 from there. And it's going to have dimensions, the T shape is going to have dimensions of 32 up here. The bottom part is a thickness of 24, and then the overall width is 100. So I'll just rough out the shape first of all. And I'm going to draw that on the front plane again. I'm going to create a sketch there. And I'll rough out the shape of that. In normal too, first of all. So we're going to have the top face of that inverted T shape is going to be level with the origin here, so on the top plane. So that's the rough kind of shape of it. And just make sure that the area is fully enclosed or you won't be able to extrude it. Okay, so I want that to be centered about the origin, and I want it to be level, horizontally level with the origin as well. So I'll put in a couple of relations here. Again, there's a few ways of doing this. To make it centered about the origin, what I could do is I take this midpoint here and have that vertically directly beneath the origin. Okay, so now we'll see if the length of that bottom line changes, then it'll be symmetrical either side of that origin. The other thing I want is these lines here. So these lines are horizontally across from the origin, so that's fine. If I make those two lines equal in length, so this line and this line, if I make these equal in length, that will make the part symmetrical about that origin that way. And finally, the last thing then is I want to put in some dimensions on that. So I think that's more or less symmetrical about the origin now, and I'll put in some dimensions on that. Where the height is 32, the height of the central part is 32, the height of the bottom part is 24, and the overall width is 20 and 100. So this was 20. $32 and 24. Okay, and that's fully defined now with that, so I'm going to close out of that. So that is sketched on the front plane back here. If I create an extrude feature of that and extrude that out by a length of 267. Okay, so that's that feature created. So the next feature I think I said I'd create was that cylindrical feature in the center of this here. So that is centered 130 millimeters down from what's my front plane, 130 millimeters down, and has an outer diameter of 75 and then a hole diameter 38 through the center of it. So I'm going to create a sketch on this top surface here. So I could use either the top plane here, or I could use the top face of the part either. I'm going to use the top plane in this case, and I'm going to create a sketch on that. And and look in normal to that. So I want to sketch a circle directly below the origin here. That's a diameter of 75 and located at the distance, the center of that is located 130 millimeters down from that face back there. Okay, now that's still not fully defined. So if you try and move it around, you see what's happening here is it hasn't picked up that relation there to be directly below the origin. So I can manually put in a relation on that there. So make that directly below the origin, 130 millimeters down, and with a diameter of 75, and that now is fully defined. Okay. So I'm going to use that sketch now to create this cylindrical feature here. And you see that this is dimensioned separately in two directions, so it's 44 millimeters up from that surface and 44 millimeters down from that surface. So if I create extruded feature again from this one here, I'm going to extrude it in two separate directions. So in direction 1 here, I'm going to go blind by a distance of 44. And I can check the box here for direction 2 as well and extrude it sort of semi-independently in that second direction there, also by a distance of 44. Okay. So you'll see now if you click on that part, you'll see that there are two separate dimensions on that, the 244 dimensions here. Okay. All right. Now at this stage, so what I've done there is I've extruded that as a solid cylinder, and I can come later and cut away the 38 millimeter hole through that. So either using a cut extrude feature or using the hole wizard. And I might actually use the hole wizard for that, just partly to demo it and partly to you have a bit more control over the type of hole. So if it was to be a threaded hole or a reamed hole or countersunk or counterbored or anything like that. Okay. So I'll leave that as a solid for now, and as I say, we can cut away that 38 millimeter hole as a separate feature. Okay, so the next feature I want to work on then is this vertical feature here, 20 millimeters thick, and kind of looking at it in this view here, looking in at the front elevation here. This is probably where I'll sketch most of that. Okay, and so that view there, the center of this circle is 130 millimeters up from the top plane, and the bottom surface of it there is 94 millimeters down from the top plane. So if I create another sketch, this time I'm going to create it on this face out here at the end. So I create another sketch here, and I will look in, so spacebar, normal to, looking in at that face there. I'm going to rough out that profile there. So using a line here, you could use lines, you could use rectangles. I'm going to create a line from here down, across, and up to the top corner there. I'll do something similar to what I did in the previous feature. I'm going to create that cylinder there as just a solid cylinder, and then I'll cut the diameter 38 hole out using the hole wizard, I think. So what I want to do is sketch a circle above the origin here, and I'll put in a relation there to make that directly above the origin. And what I want then is a line coming from this corner tangent to that circle. And another line from this corner, again tangent to the circle. Okay, so what you should find now is that with the center of the circle directly above the origin, that should stay sort of symmetrical like that, and with those two tangent relations in, then as you change the size of the circle, that will move like that. Okay, so I can dimension that circle now to be 75. And I can dimension the height of the circle to be 130 above that top face. And I believe the bottom of that feature is 94 down from that top face as well. Okay, so that sketch now is fully defined. So if I close out of that, so what I have now is a sketch with two separate areas, and I'm going to create two separate features from that, so I'll have a shared sketch. One of them is going to be, let's say if I go to create an extrusion feature from that, I'm going to extrude, let's say these three areas of that sketch. I'm going to extrude them, but I'm going to extrude them back in the opposite direction here by a depth of 20. Okay, and you can swap the direction either with these two little arrows here, or you can swap them with the, swap them using the arrow there on the, you can swap them with this arrow here. So I want to move them back in this direction here by a depth of 20 millimeters. Oh, and I need to reselect my contours again. Okay, so yeah, so that's one feature created from that sketch. If I expand out this extruded feature here and select sketch 4 again, I can use sketch 4 here then to create a separate feature, so the cylindrical feature at the top here. And if we look at that, see here that we need this dimension of 74, so we need an overall length of this thing of 74, so we want to extrude it just in one direction. So if my sketch plane is along excuse me, it's along by this face here. I don't want to extrude it in two directions from the sketch plane. So let's say I could go 13 millimeters in one direction and then 61 millimeters in the other direction, but that would leave me with no overall dimension on the length of that cylinder, and that's not what I want. So if I go highlight sketch 4 here, and I'm going to make another extrusion feature from that. This time I want to extrude that circular area here. Now, as I say, one way that you could get the geometry right if you were to say make this 13 millimeters this way and also extrude it by 61 millimeters in direction 2. So that would give you the correct geometry, but when you looked at the dimensions of it, then you would have two separate dimensions on that. You wouldn't have any dimension of 74 millimeters on that. So that's not the way I want to do it here. So instead of doing that, instead of extruding it from the sketch plane, what I'm going to do is I'm going to extrude it starting 13 millimeters offset from the sketch plane. Okay, so you'll see here that the extrusion is starting 13 millimeters away from the sketch plane, and then I can extrude it by a length of 74 back that way in the negative Z direction. Okay, and if I click on that, then you see that we have a single dimension of 74 on that there. and we also have a dimension of that 13. Okay, so that's more like what I want. Alright, so that's the basic kind of outline of the geometry of the part done. What I'll do now is I'll do the two 38mm holes. Now you could do those just as a straight extruded cut, sketch a circle on there. Or in fact you could have, when you were creating that feature in the first place, so boss extrude 3 here, I could have sketched that 38mm in sketch 3 here. But as I said, I want to do that separately, in this case just using the hole wizard here. So I'm going to open the hole wizard tool, and for the hole here I'm going to just do a plain hole, just a dowel hole, and with a custom sizing of 38. Okay, and the end condition can be through wall, or you could go up to surface either at the bottom surface. So I'm going to go through wall, and that's the whole type will be just a whole ISO dowel sizes, custom sizing 38. And for the position then, I need to essentially create a sketch on this surface here, or alternatively on the bottom surface. And in this sketch then I need to specify the location of the center point for that circle. So I'm just going to pop it down somewhere there, and then put in a relation between that point and the circle. Put in a concentric relation on them. Okay. Now I think this one is a diameter of 38 as well, so I could do that in the same. No, I'll put it in separately. Actually, I want it to be a separate feature really. So I'm going to go to the hole wizard again. My settings are the same as the previous time, so 38mm. Go to positions and then select this face here and then pick that. Now you should be able to pick up the center line, the center of that circle here. Just checking that I can't drag that, and I can't, so it's fixed in place at that location, centered on that, concentric with that circle. Okay. And again, the end condition there was through wall as well. Okay, so that's that done. The other advantage of doing these as separate features rather than doing them as part of boss extrude 3 or boss extrude 5 here, by doing them as separate features I can come along and just modify that individual feature. I could suppress that feature if I want to turn that on and off for some reason. I could suppress or unsuppress that feature, or I can come in and I can modify that feature without having to modify the whole boss extrude 3 or sketch 3, for example. So if I wanted to, I could just come in here and say, excuse me, I could go in and say, actually no, I want that to be to have a countersink on it, or I want it to be a threaded hole. I can just change that there. Okay, so sometimes it's useful to have the holes here as separate features if you want to be able to modify them individually without changing the overall geometry of that boss feature, for example. Okay, so that is the geometry more or less. So the last thing then is there's some fillets on it, on the part in general. I think they're a radius 5 fillet. And I think that is radius 5 all throughout. Actually, sorry, one last feature here, which is this web coming from here up to meet the cylindrical face up there. So you could either draw that. You could draw it on the right plane here, for example, and extrude it out mid-plane. So extrude it out in 2 directions, like so. or what I'm going to do is I'm going to draw it on this face here and extrude it up to meet that cylindrical feature up here. So I'm going to select this face here, create a new sketch, and I'm just going to sketch a rectangle on that face. So from that corner back till it's coincident with the edge here. Okay, and the dimensions of that will be 32. Okay. Now if I extrude that up in the Y direction, I want that to extrude up until it's so if you were to just extrude it up by a certain height, you might be left with a gap. So I want to extrude that, either extrude it up until it's within that cylindrical body, or alternatively you can extrude it up, instead of going blind by a certain distance, if you extrude it up until it intersects with a surface here. So if I go up to surface and then click on the cylindrical face of that part, you can see it gets extruded up until it's in contact with that cylindrical surface at all points here. Okay, and I think that then is all the geometry done except for the fillets. I'm going to delete this sketch out of here, and I will go along then and fillet. I think it's basically all of the intersections between that inverted T-shaped web and the other features. Also, there's fillets at the intersection between this vertical face and this cylindrical boss as well. Okay, so I'll select the fillet tool here, set my radius to 5 millimeters, and the items to fillet then will be essentially all the intersections here of all these internal corners essentially. So you can manually go along and pick them individually, or you can use these loops. So you'll see them highlighted in pink here. So or you can go through them. They'll vary from part to part. There should be one here, all concave edges. So all concave edges, what that will do is it'll pick any sort of internal corners. Okay, and just double check that there isn't anything in there that you don't want selected. You can manually come along and you can delete individual edges from that list there, but the all concave, what it does is it basically picks any internal corners. I think in this case that is okay. I don't see anything there that shouldn't be filleted. Okay, that. And I think that is the part finished. Okay. Right, I'm going to stop the video at that there.